All right, let's crack the code on one of the most important programming languages in history, Java. Have you ever stopped to wonder what actually makes it work and why, after all these years, it's still such a powerhouse? Well, we're about to find out.
So, the first thing you have to wrap your head around with Java is that, well, it's pretty much everywhere. Seriously, it's like this invisible force powering countless things you use every single day, whether you realize it or not.
I mean, think about it. That phone in your hand? Most Android apps are built using Java. The gigantic, super complex software that runs our banks and biggest corporations, you guessed it, that's Java's turf. It's a beast in scientific computing, it's used to analyze massive amounts of data, and it's the backbone for huge server technologies that basically run the internet. It is absolutely all over the place. And that leads to the big question, right? The core mystery we're going to solve today. How can one single language be so versatile? How can it run on your phone and a laptop and a massive web server? The answer lies in this brilliant promise that Java made a long, long time ago.
This right here, this is the phrase that changed everything. Write once, run anywhere. This was Java's knockout solution to one of the biggest, most annoying problems in the world of software.
See, before Java, making software was, well, it was a pain. If you wanted your program to work on a Windows machine and a Mac, you basically had to write it twice. You'd have two separate versions of the code. It was slow, it was expensive, it was a total headache. Java came along and said, nope, forget that, write your code just one time, and we'll make sure it runs on anything. So, how do they pull off that magic trick? The secret sauce, the magic ingredient, is something called bytecode. See, when a developer compiles their Java code, it doesn't get translated into instructions for a Mac or a PC. Instead, it gets turned into this special, intermediate language, this universal translator. Think of it like a master key. It wasn't made for one specific door, but it was cleverly designed to open all of them. But hey, write once, run anywhere isn't the whole story, not by a long shot. The reason Java became so dominant is that it's packed with a bunch of other built-in superpowers that developers absolutely love. You'll hear this word thrown around a lot when people talk about Java, robust. And in the world of programming, that's just a way of saying it's built like a tank. It's strong, it's reliable, and it's designed not to break easily.
So what makes it so tough? Well, a few key things. It handles memory really, really well, which helps avoid a ton of common crashes you see in other languages. It has this thing called garbage collection, which is kind of like an automatic cleanup crew for your computer's memory. And it's really good at handling errors gracefully. So instead of just crashing, a program can manage a problem and keep on running.
Now, this leads directly to another one of Java's huge advantages, security. And the sandbox analogy is just perfect. A Java program runs inside its own protected little area, its own sandbox. That means it can't just run wild and mess with the rest of your computer. This makes it way, way harder for viruses or other malicious code to do any real damage. And the list just keeps going. Java is multi-threaded, which means it can juggle a bunch of tasks at the same time, super important for modern apps. It was built from the ground up to be distributed, meaning it's designed to work across the internet. And it's dynamic, so it can adapt and even load new code while it's running. It really is a programming powerhouse. Okay, so we've got this universal language called bytecode, and all these great features like security and reliability. But what's the actual thing that's doing all the work? What's translating the code and making sure all the rules are followed? Well, let's meet the real heart of the Java system. This is it, the Java Virtual Machine, or JVM. You can think of it as the engine inside the machine. Every single computer that wants to run Java needs a JVM. Its entire job is to take that universal bytecode we talked about and, in real time, translate it into the specific native instructions that that particular computer can actually understand and execute. It's the universal translator.
So let's put it all together one more time. It's a simple three-step dance. Step 1, a developer writes their program in Java. Step 2, the compiler turns that human-readable code into the universal bytecode. And step 3, the JVM on your computer, doesn't matter if it's a Mac, a PC, a phone, translates that bytecode on the spot and runs the program. It's simple, it's elegant, and it's incredibly powerful.
Okay, I know what some of you might be thinking. If you've ever tried to install something that needs Java, you've probably run into this alphabet soup of acronyms, right? JDK, JRE, JVM. What on earth is the difference? It can be super confusing, but it's actually really simple. Let's clear it up right now.
First up, you've got the JDK, the Java Development Kit. The best way to think of this is the complete developer's toolbox. It's got the hammer, the screwdriver, the whole shebang, everything a programmer needs to write, build, and test their Java programs.
Then there's the JRE, the Java Runtime Environment. Now, this is what most of us have on our computers. You don't need the whole toolbox if all you want to do is run a Java program, right? The JRE is just the essential kit that lets you do that.
So here's how it all fits together, from biggest to smallest. The JDK is the whole toolbox for developers. Inside that toolbox, you'll find the JRE, which is the smaller kit just for running programs. And at the very core of that kit is the engine itself, the JVM. It's like a set of nesting dolls. The big toolbox contains the runtime kit, and the runtime kit contains the engine. Simple as that.
Now, Java's been around for over 25 years. I mean, in the tech world, that's practically ancient. So why are we still talking about it? Because its core idea wasn't just clever for its time. It was visionary. It actually helped build the foundation for the tech world we live in today. That idea of running code inside a virtual machine, of separating the software from the physical hardware it's on, that was the real revolution. It's the direct ancestor to so much of our modern tech. Think about cloud computing, where your apps run on some unknown server in a massive data center, or container technologies like Docker. All of those ideas owe a massive debt to the path that Java and the JVM blazed decades ago.
So in the end, Java's true legacy isn't just a programming language. It's an idea, a really powerful one. In a world where tech seems to change every 5 minutes, Java's philosophy of write once, run anywhere is this incredible lesson in how you build something that lasts. It teaches us that the best solutions aren't the ones tied to the machines of today, but the ones that are flexible enough for the machines of tomorrow.